Hi everyone, it's Coach Fred here, and I'm making this video today on linear inequalities that you learned in Algebra 1. Um, and linear inequalities are very similar to linear equations. And you might notice that this one I have here is in the form y equals mx plus b, but instead of having an equal sign, it has an inequality sign. So you may have learned that you could either have y's greater than, in this case, 3x plus 4, or y's greater than or equal to negative 3x plus 4. And the only difference between those is that in a linear inequality, if it's greater than, it would be a dotted line. And if it's greater than or equal to, it would be a solid line. And you may remember all of that. But you treat it just like a line equation. You graph the line. All right, so I'm going to graph. I've got a y-intercept of 0, 4, and I have a slope of negative 3. So I know that I have a negative slope. So I'm going to go up to my y-intercept of 4. I'm going to plot the point, and then I'm going to go down 3 and over 1. And then I'm going to go down 3 again. So 1, 2, 3, and over 1. And then I'm going to draw a line through that. Now this is going to be a solid line because it's equal to. So let me fix my line here. Try to get it through those points. Okay. Now, the most important thing, though, is that it's an inequality. So it's not going to just have values that are on that line that make this true. So this is where we had to deal with shading, okay? Finding a shaded region, okay? So the easiest way to find the shaded region to solve the inequality is to use a test point. Pick a point that's not on the graph and see if that point actually makes the inequality true. If it does, then that point is in the shaded region. So I always like to use the point 0, 0 if my line doesn't go through it. So I'm going to take the point 0, 0. I'm going to plug it right in. So 0 is greater than or equal to negative 3 times 0 plus 4. All right, so that gives me 0 is greater than or equal to 4. Well, 0 is not greater than or equal to 4, so that tells me that that point cannot be in the shaded area. So that means I have to shade on the other side of the line. So that is the solution set to the inequality. Any single coordinate anywhere in this shaded area above the line will solve and make this inequality true. So it has an infinite number of solutions. Now, how can we apply that rule and that idea to harder equations on a standardized test? Well, recently I saw one that looked like this. Actually, let me scroll down a little bit here. Okay, so it was a question number 49, so it's a harder level, and it said the shaded region in the graph below represents the solution set to which of the following systems of inequalities? Well, here I have a circle, and hopefully you recognize that's the equation of a circle. Okay, the equation of a circle. That's in the form x minus h squared plus y minus k squared equals r squared. And then this is a line in the form y equals mx plus b. So I'm just going to actually write it right here for you. All right, so I started there. I noticed I did that vertical scan that I'm really big on, and I noticed that all of the y equations, all of these were the y equations, but this one wasn't. And this is kind of like that distracting answer. That has really had nothing to do with this. So I got rid of E right off the bat. And I said, it's either y is less than negative x plus 2 or y is greater than negative x plus 2. And I could see that actually the shading was below the line, so I assumed it was y is less than, but I want to use the test point to make sure. So I picked 0, 0, I plugged it in to this first inequality here, and I said 0 is less than 0 plus 2. So 0 is less than 2. So I knew that it needed to be y's less than. So I got rid of b and I got rid of c. So I took care of that first inequality. Now I'm going to do the exact same thing with the second inequality. Took the test point 0, 0. I'm going to see if it makes the inequality true, because then it would be in the shaded region. So I did 0 minus 1 squared, which is 1, plus 0 minus 2 squared, so negative 2 squared, which is 4. 1 plus 4 is 5. That is less than 9. So that means that 0, 0 is in the shaded region on the circle as well. So my answer is A. So that idea of a test point can really be helpful. And it even talked about the shaded region, and it talked about the solution set to the systems of inequalities. And the reason it's a system is because there's two two inequalities or two equations that you're dealing with, and it's looking for the overlapping solution set. All right, so that's how linear inequalities can be used on a standardized test. Have a great day.